My name is Tisetso Mukhutle. I'll be taking you through the three concepts here of natural sciences in grade 8. That is expansion and contraction, and how they are related to another concept called pressure. Okay, this is the overview of what we'll be talking about today. I'll explain the concepts, expansion and contraction. Then I will describe how solids, liquids, and gases expand, which are our three states of matter. Then I will give you some examples of everyday consequences of an expansion of materials due to heat. And then I'll come to that last concept called pressure. And lastly, but not least, but I'll make reference to pressure in solids and liquids. And lastly, I'll then describe the effect of the change of temperature on the pressure of a gas. Okay, to start off, learners, there is no way you can understand the concept of pressure, expansion, contraction, if you do not know much about the particle model of matter. So I thought it is the best way to start by first giving ourselves a revision about the model. The first thing about the model, it says all substances are made of particles that are too small to see. And these particles, we all know those particles are either atoms or molecules. So we know all the materials are made of those small particles that we cannot see with our naked eye. Now, the next thing about the model, it says, although we know that particles are made up of, materials are made up of particles, we also know that there are spaces between the particles within those materials. Then again, we know that the particles are not stationary. They are always in a motion. And the fourth one is that if you heat a material, the particles will start to move faster and faster as the temperature increases. And if you take that material and you cool it, the particles that make up that material will slow down in motion. And then the other thing, remember, we also learned about the three states of matter. We also know that particles are arranged differently in solid, liquid, and gases. We know in a solid, they are packed together, tightly packed, and then they are loosely arranged in liquids, and they are far apart in gases. Now let's now talk about the expansion of and contraction concepts. Remember, we'll always relate it to what we talked about now, which is the particle model of matter. Now let us first look at expansion. Now, if you look at a material on the left-hand side, and we compare to the same material on the right-hand side, we see that on the left-hand side, before the material was heated, the particles were closer to one another, and then the material was heated, and now we see that the particles are far apart from one another. Or we can differently say the spaces between the particles increases if you heat a material. That's exactly what happened there. Okay, now let us summarize this diagram. It says here the particle model of matter suggests to us that materials expand when heated. It means they grow in size. When heated, the particles, we know that they vibrate more, This means that because they need to move faster, they need more space. It means then they move far apart from one another. And as a result, they make the material to grow in size and expand. Now, here is the opposite. Already here we have a material that was heated. We know that the particles are far apart, and then we cool the material. Notice that when we cool the materials, the particles, they move towards one another, and the spaces become smaller and smaller. The other thing that you should note about the two diagrams is that in both diagrams, the spaces are either growing bigger or becoming smaller. The size of the particles themselves, you see the same size, they are the same size. So it means contraction and expansion does not affect the size of particles or the size of atoms. It only affects the size of the spaces between the particles. So let's summarize the contraction. The contraction, it says the opposite happens when the substances are cooled, meaning the whole process here is the reverse of expansion. What happens is that the particles vibrate or move less. And as they move less, they need less space for movement. So that is why they come closer to one another. And as a result, we say the material contracts or shrinks in size. Now, the most important thing about the expansion and the contraction concepts, these are the most important 3 points that you must take note of. The expansion occurs even when the material does not change its state of matter. What do we mean by that? If you are going to heat an iron rod, that iron rod is gonna, the particles that make up the iron rod will start to vibrate more and more, and even the space will start to become more and more. But it doesn't mean as you continue heating the iron rod, it will change the state. Of course, it can change state if it exceeds a particular temperature. The same way with liquids. If you heat water, for instance, you will find that the particles within, or the molecules within the water, they will start moving faster and faster. And then the spaces between the molecules will become bigger and bigger. But the phase of the matter is not changing. It will still remain liquid until such time the forces between the particles that attract the particles is so low, then the matter can now change into a gas. The second thing, the particles do not increase in size. Very important, I mentioned that. Lastly, it is the spaces that get larger between particles. Okay, let us now look at the 3 states of matter. Expansion in solids. Solids cannot be compressed. That is, spaces cannot be made smaller. When a solid substance is heated, particles need more space to vibrate. It needs more space to vibrate. Metal railway tracks, which are made of a solid material, expand when becoming hot, causing them to grow longer. Therefore, solid substances expand to allow more vibration of particles. Now let us look at this example here. Here is a solid iron railway track. We know that it is made up of particles that are closely packed like you see here. Now, due to scorching heat from the sun, the particles of the metal of the railway tracks can start to vibrate more and create even more space. But as we know, the solids does not have room to grow. It doesn't have enough space to grow so that as to accommodate the movement of the vibrating particles. So what happens is that the railway track will grow longer, but because there's very little room for growing longer, they end up buckling or bending. So that is the everyday consequence of expansion and contraction. Let us look now at the expansion in liquids. If you look at this diagram on the left here, we see that the liquid is represented in red color. If we hit the bottom of this container that is containing the liquid rises from being 20, occupying a volume of 20 milliliters to occupying a volume of 60 milliliters. Why is that happening? Let us just go through our points here. It says liquids cannot be compressed to fit in a small container. Meaning, if the liquid was originally 60 milliliters, we cannot make it to become 20 milliliters. But if it was 20 milliliters, it is possible that we can make it 60 milliliters, occupy a volume of 60 milliliters when we heat the liquid. All right, let's look at the temperature effect. When the temperature of a liquid rises, the particles turn and move a lot more. We already know that, causing the substance between the particles to expand. Now, as you heat this liquid on the left, the particles move faster and they need more room or space for movement. And the spaces are growing bigger. So the only way for the liquid to move is upward. That is why the level of the liquid rises on the right. Most liquids expand when heated. An example is that of a thermometer. Now let us look how expansion occurs in gases. Now you'll realize in the first container, we still have the same number of particles of gas, which is 2, 4, 6, 7. On this one, we still have the same number of particles. The only difference between the two containers, it is the space between the two. Okay, and this is a situation that happens when you heat the gas. It will try and occupy as much space as possible. If you cool the gas, it will try and occupy as little space as possible. Right, in this case, if the gas is heated there, a heated gas is released from a can here in that air balloon. We know that the air expands, so it will rise and fill the whole of the balloon up there. Hence, the balloon will rise. Now again, just like the liquids, or differently like the liquids, gases can be compressed. Remember, the liquids, they cannot be compressed. It means if you've got a gas that is filling a bigger container, it can be compressed, made to fit in a smaller container. Gases always take the shape of and the size of the container. So if you transfer gas from a smaller container to a larger container, it will spread out to fill the rest of the container. Gases expand a lot more than liquids. When heated, means more space between the gas particles than it is with the liquid particles. Now, the summary of what we've been talking about, it says here, as the temperature of a solid, a liquid, or a gas increases, one thing that we know, the spaces between the atoms and the molecules of that substance will increase, causing the substance or the material to expand or grow in size. As the temperature of a solid, liquid, or gas decreases, the opposite happens. The spaces between the atoms and the molecules of a substance decreases, causing the substance to contract or becoming smaller. Expansion or contraction due to the changes in temperature is not permanent. What do we mean by that? We know if you have heated an iron rod, we know it will grow bigger in size. Okay, but when you cool it, then it contracts, becoming smaller again. The number of atoms does not change. We have talked about irrespective whether you cool a material or you heat the material. It's not only the number of atoms, even the size of atoms does not increase or decrease. Different types of solids, liquids, or gases expand or contract differently. Now let's look at pressure. Now let us look at the two scenarios here. There's a diagram on the left. It illustrates a sharp knife and a very blunt knife or a dull knife. Now both the knives are in contact with the surface here. Notice that the knife that is sharp is in contact with the surface only on a small area, whereas the blunt knife or the dull knife is in contact with a bigger surface between it's in contact on a large area between the surface and the knife itself. And then on the right, we see that someone is wearing a heel here, and the other person is wearing a flat shoe. Notice that between the ground, both shoes, they only touch the ground with different surface area. With the heel here, it is only in contact with the ground only on a small area. And then here, the shoe is on contact with the ground, in contact with the ground on a larger area. So what is pressure? Let us look at what pressure is. It says here, pressure describes how force is spread over an area. If you push a knife here, you are applying force onto the surface. If you push a knife here, you are applying force. If you are standing on the ground, you are applying force on the ground, all right, directly downward. Now, the force is described as the force spread over the area of contact. So that is, pressure depends on the area over which the force is applied. Secondly, it is the measure of how much force is acting. That means pressure depends on the amount of force. So we can make a relationship between the area and force by this equation. Pressure is equals to force divided by area. The smaller the area, the higher the pressure. What does that mean? It means if you divide here by a small number, you are going to get a bigger answer, which means the more pressure. Okay, let us just summarize here about pressure in liquids and gases. If you look at liquids here, you fill the container with a liquid, and then you make 3 holes on the side of the container. So you actually pierce 3 holes, and then what happens is the liquid will escape through the holes. But do you realize that it escapes with a larger force at the bottom hole here than at the top hole? So how do we describe that? In terms of pressure, we say a liquid exerts pressure in all directions, meaning all the particles of a liquid, they are always in contact or hitting the surface, the side of the container at all times. Now, at any point in a liquid, the pressure is the same in all directions. Pressure of a liquid increases from shallow to deeper level. Although it is the same for every particle But as for the level of depth, if it is at the lower depth, we see that pressure against the surface of the container becomes larger. As you rise up, the pressure against the surface becomes lesser and lesser. In the case of gases, as gas exerts pressure because of the collisions of particles with each other and against the sides of the container. A gas exerts pressure because of the collisions of particles with each other. Remember, for a pressure to be there must be contact. It means the particles must be hitting the surface of the container with a force, okay? And the area at which those particles are hitting the surface, it means it is the area that is used to determine the pressure. So the more the number of particles in a container, the more the collisions of the particles, hence the increase in pressure. Because there are many particles that are hitting the surface, it means there are too many forces from different particles. We can add them all up. It means it will make a bigger force of all the particles, meaning whenever the particles are moving faster in a container of a liquid, for example, or gas, it means there are many forces of those particles on the side of the container. And as a result, we know from the formula of force, we say pressure is equals to force divided by area. So it means the force will be larger, hence the pressure will be larger. Okay, so in summary, and lastly, pressure is the measure of how much force is acting on a certain area. And pressure can be increased in two ways. You either increase the force of the particles by either heating the material or the solid substance or whatever. As long as you can heat it, you know you're going to increase the movement of particles, which will in turn increase the force. Or you can increase the area of the force, meaning you can actually transfer a gas to a smaller container. If you transfer a gas from a larger container to a smaller container, because there are now many particles that have to hit against the wall of the container, it means there will be more force against the wall of the container, hence the pressure increases if you decrease the area. Remember, you need to relate the formula in order to determine whether the pressure is high or low. The force is high, we know the pressure is high. The area of contact is less, it means the pressure is high. The equation is used to determine the pressure of a substance. And then pressure acts in all directions in fluids and liquids. And lastly, as you move higher and higher within a liquid, as the particles, as they go higher and higher within a liquid in a container, the pressure decreases. And then as particles go deeper and deeper in water or in a liquid, the pressure increases. That will be the end of the lesson, grade 9. Thank you very much for having joined this lesson. Till we meet in the next lesson. Thank you very much.